Alrighty. Okay. Let's look now at number 3. So we're still just simplifying it. Okay, let's look at our numerator. N minus 5. Can I factor it?
No.
No. So let's look at our denominator. In fact, we're going to just rewrite it. M minus 5 on top. Look at my denominator. Okay, 2 terms. What can I divide both 2 and 10 by? 2. I can divide out a 2. And how many m's can I take from each? 1. So I can factor out a 2m. Okay, well remember factoring is just division, so 2 divided by 2 is 1. 2 m's take away 1m is 1m. Negative 10 divided by 2 is what?
Negative 10 divided by 2?
Negative 5.
Negative 5. All right.
So negative 5. No, m negative 5.
Yes. Okay. So then my pieces that are exactly the same, m minus 5 and m minus 5. Again, what's left on top?
1.
1. We have to write them on top, and 2m on bottom. 1 over 2m. Okay.
Pause. Hold on. Wait, go back home.
Okay, last one where we're just factoring and canceling. Okay, then we'll get to the real stuff. Okay, my numerator, r plus 8. Can I factor?
No.
No.
So
So let's just keep them the same. R plus 8 on top.
Got it.
Oh.
My denominator, 3 terms here, and they don't have anything in common, so we need to play what? Number game. What multiplies to negative 72? 2 numbers that multiply to negative 72 and add to negative 1 in the middle.
72.
Not 8 and 8. I agree 8 is probably one of them. What's 72 divided by 8?
9.
9. Beautiful. So I agree. One of them, let's see, and I want it to be negative 1, so I want to make my 9 negative. R minus 9. And R plus 8. Negative 9 times 8, negative 72. Negative 9 plus 8, negative 1. Okay. What cancels?
Nothing. I'm just kidding.
R plus 8, R plus 8. What's left on top? 1. And R minus 9 left on bottom. Okay. So that's just a little refresher on simplifying rationals. Factor when you can and cancel. That's all we got to do.
Oh no.
Okay. Now, everybody turn your paper over. Because we need to remind ourselves, let's go back to whatever grade it was in elementary school, on how to add fractions. We need to remind ourselves how to add fractions. So let's say I have 2/5 and it's being added to 1/3.
Don't you just do it across?
No.
Nope.
Okay.
Yes, kind of. Kind of, Jameson, you got it. So, in order to add fractions, put this note on your paper. The denominators have to be the same. Denominators must be the same, meaning I cannot add 1/5 to 1/3. They have to be the same type of fraction in order to add them. Right now, I cannot add them how they are. Okay, everybody has that note on the back of their paper?
Yes.
Okay, so here's how we make the denominators the same, kind of like what Jameson was just showing us. I need to take this 3 and it needs to multiply to that guy in order to make that denominator the same, right? I need to take that 5 and multiply it to that guy.
Oh, the crisscross method.
Because now our denominators are both
I didn't really learn this very well though.
15.
I think I do.
Okay. I know. I love how enthusiastic we are. Let's keep the comments to a minimum. Okay. They're both 15 on bottom now. They're the same. This one turned into 2 times 3, which is what?
2 times.
What's 2 times
6.
3? 6. Okay, that first fraction turned into 6 fifteenths. What is 1 times 5? The next one had to multiply by 5, which was 5. Okay, they now are the same denominator. 6 fifteenths plus 5 fifteenths. How many fifteenths do I have?
2.
11.
Wait.
6 plus 5? 11.
Oh, never mind. I was looking at the bottom.
15ths.
The way you asked the question confused me.
Sorry.
Oh, I see. You have
Yeah.
to get the same
6.
denominator
How
on
many
the bottom.
6
do
of
you
something
have? Like,
plus
1, 2.
5 of that thing gave me 11 of that thing.
Okay,
You
let's
said,
go to high school.
How many 15s do I have? 2.
Oh.
11. 6 of them right
Okay,
here.
no,
5
the
of them right
question
there.
was asked was-
Two fractions.
Yeah. No,
11
when
15s.
You asked the question, it thought you said how many, like, 15s are there? There's
Oh,
2.
gotcha. Okay, so that is the whole premise of what we're doing today and actually next time. Okay, the denominators have to be the same in order to add and subtract them. Today we're just working on adding. So let's turn your paper over.
Yes.
Darn it, I have the same. We have to make them.
Okay, you guys have already noticed that this denominator, think of that as a piece, is not the same as this piece and that piece.
Nope.
Oh, no.
And they have no pieces in common either. So, just like we had to do with our little fractions, we had to crisscross them. So, we're going to take b plus 3, multiply it to that guy, and I need to take 3 times b minus 2, the whole denominator over there, and multiply it to that guy. Take the denominator, multiply it to the one across. Denominator, multiply it across. If you want to draw little arrows, you can do that. Okay, so here's the thing. I'm just going to forget about the denominators for a second. Really, the numerators is what we're working with the most here. Okay, so this numerator turns into 6 times 3 times b minus 2. Okay, first of all, what is 6 times 3? What's that going to give me?
18.
18. Okay, now we need to distribute the 18. 18 times b gives me what?
18.
18b. 18 times negative 2. What is 18 times negative 2? Use a calculator if you need to.
Negative 36.
Negative 36. Okay, so that whole first numerator changed from a 6 all the way to that guy because we had to multiply by the pieces that it needed. Needed those pieces. Okay, this guy. This is going to turn into 4 times b plus 3. Okay, that's that piece right there. 4 times b plus 3. We can go straight to distributing. What's 4 times b?
4b.
4b. And I'm just going to write it down here. Plus 4b. What's 4 times 3?
12.
Positive 12. Okay, again, I'm just forgetting about the denominators for a second. We'll put him back onto our answer in a second. But now we want to simplify, combine like terms on my numerators. So where are my like terms right here? Okay.
18b and 4b.
What is 18 plus 4?
22.
22. So I get 22b on top. Other like terms I can combine?
No. Negative 36 and 12. Okay. Yeah, no, you can combine those 12.
What is negative 36? I'm at negative 36, but then I add 12. What's that going to give me?
Negative 24.
20.
Oh, yes. Yep. So negative 24. Okay. There's our numerator. Now all we got to do is put our denominator on. Well, it just needs all the pieces. Okay, our first piece was b plus 3. Our second piece was the 3. And our last piece was b minus 2. And guess what? That's it.
What?
That is the final answer.
That was not bad at all.
That was pretty bad.
Not too bad. Not too bad.
I almost cried.
Okay?
Almost cried.
So let's try it again. Number 6 actually isn't as mean as number 5.
Good.
A little mindless.
Do our denominators look the same?
No. Besides top.
Do we
they have
care?
an end.
Do we care about the numerators though?
No, but they both have ends.
They both have ends. I agree. But those are totally different pieces. N minus 2 is not the same as n plus 5. Correct?
No.
Correct. So we got to do the same thing. Take your n plus 5. He multiplies to that guy. Take your n minus 2. He multiplies to that guy. That step is what we're doing to make the denominators the same. Okay? So now let's just forget about the denominators for a second. Just work with these pieces. So first I have 6 times n plus 5. Okay, let's figure out what that is. 6 times n plus 5. So what is 6 times n?
6 times.
6n. 6 times 5?
30.
Positive 30. Okay, then we're adding it to this next piece. So 6 times n minus 2. What's 6 times n?
6 times.
6n. What's 6 times negative 2?
12.
Negative 12.
Okay. That's just our numerator. Now let's go ahead and combine like terms. Where are my like terms with this guy? Kaylee?
6n and 6n.
Okay, if I have 6 and I'm adding 6, how many n's do I have?
12n.
12n.
Oh, yeah.
Other like terms?
30 negative 12.
What is 30 minus 12?
That's gonna be
18.
You beat me to the answer.
Okay, there's our numerator.
Race now.
Your denominator
Stuff.
is just all the pieces. Okay, our piece was n minus 2 and n plus 5. And that's it.
Awesome.
You just have to make the denominators the same, combine like terms, and there you go.
Not as bad as
Not that
that.
bad.
Not as bad. Okay, let's look at number 7 though.
Number 7.
You're welcome. Okay. Don't worry about the numerators yet. Look at your denominators. I have x plus 5 and 6. Are those denominators the same at all?
No.
No. Which means 6 needs to be multiplied to that numerator.
Oh.
X plus 5 needs to be multiplied to that numerator. Okay, just take each piece, multiply it. Okay, so let's do our first numerator. So I have, and I'm going to write this a little differently, 6 times 6x minus 5 is that first piece. Let's figure out what that's going to be. 6 times 6x?
36x.
36x. 6 times negative 5?
Negative 30.
Negative 30. Okay, now it's being added to our next piece. 3 times x plus 5. Let's figure out what that's going to be. 3 times x.
3x.
I need to write it down.
And
15.
nice job.
God, come on.
Okay, so those are just our numerators. Remember, make the denominators the same, then just work with the numerators for a second.
Try and write it down. I can't write down that
Where are my like terms? I just have to combine.
3x and 36x.
Negative 30 and positive 15.
Great job. Okay. What is 36 plus 3 going to turn into?
39.
So we get 39x on top. Negative 30 plus 15. Negative
Wait.
30
That's
plus.
That's gonna be 15.
Positive 15?
No, negative 15. Negative 15.
Oh, okay. I didn't know that was right. Okay, I thought my calculator was tweaking.
Oh.
Okay, so there's our numerator.
Goofy.
Now just put your pieces to the denominator. 6 was our first piece. Well, we like to put him in front. And x plus 5 was our other piece.
I like putting 6 first.
Yeah, usually we like putting the lone number in front of the parentheses.
We like putting our guests first
My brain
at
is
this
at full time.
hotel.
Okay.
Never mind, it's
The
not.
Is this what you want us
weekend
to add?
hotels be
Like,
like.
with
we
the-
No,
like
definitely not.
Why?
You're being way too rowdy, and you're driving me nuts a little bit. Okay,
So don't do that.
so number 8. Look at our denominators. 4r squared
our-
and r minus 1. Same pieces?
No.
No. Okay, so that's okay. Just take that piece, multiply it across, 4r squared,
Wait, can you? Never mind.
r minus 1, multiply to the 3. Just multiply across. Again, this step is what's making the denominators the same so that we actually can add them. We can combine like terms in a minute. Okay, so let's take our first numerator piece. We got 3 times r minus 1. 3 times r. 3r. 3 times negative 1.
-3.
Negative 3. Okay, then it's being added to our next piece. So plus 3r times 4r squared. Let's think about this.
How do you do that?
Okay, first multiply the coefficients. What's 3 times 4 going to give me? 12.
12r cubed.
Nice. So then I have 3 r's. So 12r cubed. Nice. So there's our numerator. Do we have any like terms?
No.
No, because this r doesn't have a cubed, that doesn't have an r, and that is r cubed. So guess what?
That's right.
That's our numerator. I like writing it to where the biggest degree comes first. So 12r cubed plus 3r minus 3. Guess what? That doesn't really matter. You could have kept it in the same order. Doesn't matter. Mathematicians like it written like that.
They like it neat.
It's called descending order.
They like making.
Okay, and then just put your pieces to the denominator on bottom. We add 4r squared and r minus 1.
Oh wait, that's gonna turn into. Oh, that's cool. That is cool.
And there we go. Okay, adding and subtracting, make the denominators the same, combine like terms. That's basically
that
all
makes
we're
sense.
doing. I might want to skip number 9. Yep, let's skip number 9.
9.
See you 9. Okay, let's look at number 10.
Comes back.
Okay, are we ready? Are we ready? This clump? This clump? Thank you. Thank you. Now, this one might throw you off a little. My two denominators, a minus 5, 2a minus 5. Do they have anything in common?
Minus
Yes,
5.
everything besides the 2.
Yeah, that's what's going to throw you off. You're going to say a minus 5 is the same as a minus 5. I agree. But it's not the same piece. It has to be the exact same piece. So, that actually makes it easy on us. Take this piece, multiply it across. 2a minus 5. Take that piece, multiply it across. A minus 5. So they look similar. They are not the same piece, though. Does that make sense? They look similar, but not all the way. Okay, so let's go ahead and multiply. Let's see what we get. First little piece, 4 times 2a minus 5. What's 4 times 2a, okay? 8a. 4 times negative 5, okay?
Negative 20.
Negative 20. It's being added to my next piece, 4a times a minus 5. Ooh.
I'm about to end this man's whole career.
What is 4a times another a, Jameson?
4a squared.
4a squared. And 4a times negative 5.
Negative 20. Yes.
Negative 20, 20, 20a. Good job.
So you're just putting the problem back together.
Pretty much, kind of. Okay, where are my like terms that I can combine on this numerator? Donovan, where are they?
It's ready.
Ooh, so close. Those look really similar, but that guy doesn't have an A, but that one does. So where are my like terms?
8 and 8, 8 and 4.
No, 28, negative 28, A with A.
Oh, no way, it's got an A.
We have 8A, yes, and negative 20A.
Yeah, that's what I said.
So what is 8 minus 20?
20. I'm just kidding.
Negative
Isaac?
12A.
Beautiful. We got negative 12A. Can't combine these guys. So again, I just like writing them in descending order, meaning this guy would come first. 4A squared, he's the highest. Minus 20 would come last. There's our numerator. Our denominator was just our pieces. We had A minus 5 as our first piece. 2A minus 5 as our second piece. Woo.
We got the answer.